question asks us to predict which CH bond will react faster with a bromine radical. I've drawn in several of the CH bonds. Some of the carbons have more hydrogens attached, but I'm only drawing one for each carbon. We can rule some of these carbon-hydrogen bonds out immediately. Any carbon attached to an sp2 hybridized carbon will have a larger bond association energy and will react slower. So none of the carbons attached to the alkene will react fastest. That leaves the carbons attached to sp3 hybridized carbons, the hydrogens attached to sp3 hybridized carbons. The two on the end are the same, so really we're only looking at these two carbon-hydrogen bonds. If we look at these two carbon-hydrogen bonds, they're both adjacent to an alkene, so they're both allylic. That means both radicals will be stabilized by resonance with the alkene. The main difference is this central carbon is stabilized by resonance with two alkenes. It's doubly allylic. The radical that forms here can be stabilized by resonance with both alkenes on either side. The radical that forms on the primary carbon can only be stabilized by resonance with one of the alkenes. Stabilized by resonance over a larger volume with more pi bonds means that this radical will ultimately be more stable. And if this radical is more stable, that means this carbon-hydrogen bond will react faster with the bromine radical.